Hi, welcome to Exam Debug. I'm Chris McKenna, and today we're going to be having a look at input devices in a little bit more detail. So we already did a class before. It's a general overview on what an input device is, as well as storage and processing and output. But today we're going to look at input devices. So for those of you who didn't see the last video, an input device is something that allows us to put data into a system or into a computer. For example, a keyboard, when we type it, we're using our physical touch to put it into an electronic medium in our system. Okay, so to start with, this part of the course is a lot of memorization. There's a lot of things that you have to learn, and so it's not maybe the most exciting part of the course, but it's quite good to have a base of different devices, because it will help you later talk more fluently when it comes to the problem solving and things like that. So don't worry that the course, the IGCSE ICT course, does get a bit more interesting, so please don't be put off by all the memorization. To begin with though, there are certain devices that I'm just going to assume that you know about. If you don't, you should go and figure these out for yourself and research them. For example, microphones, digital cameras, scanners, graphics tablets, mice, keyboards, remote controls. I'm going to assume you have a basic grounding in these. Because to go through them all would just bore most people to death, including myself. And I really don't want to bore you or myself. So today we're going to look at the devices that are maybe a bit more uncommon. So the uncommon input devices. But before we get started, maybe if you're not too sure about these, can you name all these devices? And can you give me an advantage and disadvantage of each one? So maybe scroll those down, write those down, and see, make sure. If not, you can Google the answers. Alright, so let's have a look then. Oh yeah, so when you're doing this, one of the best things you can do is actually to write some of this stuff down as you go along. So just listening to me, you're not going to remember all of it. There's a lot of information, so I suggest you write it down or use a mind map or something to help you remember all of these things. Again, probably, as I mentioned before, doing your own investigation and finding out about these things is going to be much better if you are in a class. Assign a device to each person, research it and present it to the class rather than listening to me. But if you're by yourself or you're doing this as extra study onto your class, then stay with us. Okay, so let's start with some user entry devices. So again, these are all input devices, but specifically this is for people to enter things into the computer or into the system. So the first one we have here is a concept keyboard. So a concept keyboard is, as you might see here, you have preset buttons that have a specific function. And usually these are custom designed for a company. So I used to work at McDonald's. I was a purveyor of dangerous fast food. This was when I was at university. I worked there part-time, and we had to use concept keyboards. So when people ordered a hamburger, all you had to do was click the hamburger button or click the hamburger meal button, and it entered it into the system. So why have these? Why not have a keyboard? Well, it's much faster to enter the data than having to type in hamburger, for example. Likewise, it reduces the error. So it's easy to make a mistake when typing, and it's tamper-proof. So maybe someone who's working at McDonald's thinks they're not getting paid enough money, as many people who worked there did think they weren't getting enough money. So maybe they wanted to cheat the system. It would be much easier if they have, a keyboard where they can, program, or they have other ways to input data into the system. Whereas with a concept keyboard, your ability to hack, your ability to cause damage is much more limited. Okay. Our next one, which you're probably familiar with from ATMs or old telephones even, is a numeric keypad. So numeric keypads, quite obviously, are good for entering numbers. So on an ATM, for example, it's quite rare that you have to put in a person's name, although here in Indonesia sometimes you do have to do that. But generally it's specific for number entry. And it's really good for small devices where you don't have the space for a full keyboard. So I know some people like the old Blackberries where they have the full keyboards, but for other people those keys are too small, and it's better to have slightly bigger keys but have to click it many times to type something. Even then, if the keys are slightly bigger, it can be difficult to use the small keys for some people. It's really bad for text. So some of you might remember the old mobile phones, and you would have to, for example, if I wanted to type the letter C or I wanted to type my name, I would have to press 222 to get the letter C, 44 to get the letter H, 777 to get the letter R, and so on. So it's quite bad and slow for typing text. And it's not intuitive, especially for entering text. Yeah. Okay, so we're still on user entry, but we're kind of changed here. We're more kind of comparing to a mouse now. So this one here, I have one in front of me, is a touchpad. So a touchpad is very similar to a mouse, but on the positive side, it's integrated into the computer, which makes it to some extent more portable. At least it makes your computer more portable, if that makes sense. The problem is it's more difficult to use than a mouse. I love playing games. If you've ever tried to play a fast-paced game using a touchpad instead of a mouse, you'll understand what I'm talking about here. Oh, sorry, motorbike. You'll understand what I'm talking about here. The touchpad is much more difficult to use. This next one down here is again similar to a mouse, but it's called a tracker ball. So you'll notice that the tracker ball, this ball is on the outside. So this stays still on the desk. You don't move it around like you do a mouse. It stays where it is. And instead you use your fingers to control where the cursor, where the pointer is going to go. So these are often used in things like architecture, I believe. And they're more accurate for positioning than a mouse, so you can be very nuanced with your positioning. They take up less space in the desk, so for my mouse, I've got my mouse mat. It takes up a fair chunk of the desk, whereas a tracker ball is going to be stationary, so it doesn't have to move around. You don't have to worry about knocking over your can of Coke. And easier for some people with hand problems. So if you don't have that wrist movement, if you just have the finger ability, then it's much easier for you just to use your fingers to control the tracker ball. The big downside of tracker balls, though, is, well, first of all, they're more expensive, although I should say that's only really because people don't use them as much. If they were more common, they would be cheaper, but they're not standard. So, just like using a mouse, takes a bit of time to get used to for people the first few times. Say, like if you ever have your grandparents and try and get them to use a mouse, you'll see how they struggle in the beginning, or young children also sometimes struggle. And it does actually take a bit of learning, and you get comfortable using a mouse, whereas a tracker ball, again, it's better in some ways, but it takes time to learn. And so you might spend your time getting comfortable with this, but then you go to school, and in our computer lab at school, we have mice. And so, or maybe you go to work, and you have to use a mouse again. So It's not standard is probably its biggest disadvantage, and this links into why it's more expensive. Again, still talking about these pointer controllers to some extent, we have a very old looking joystick. So a joystick is used for games, of course. You can get very advanced joysticks these days, some really cool ones. And they're also used in simulators. So if you're learning to fly a plane, you don't jump in the plane and start flying or start trying to pilot it. First of all, you practice using a joystick. So you can control in 3 dimensions, which is kind of different from a mouse, but it gives you that 3-dimensional control if you want to fly a X-Wing or TIE Fighter or something like that. It makes it a lot more easy to control your spaceship. Difficulty is, if you ever try to use one of these to control your mouse, it's very tricky to be accurate with it. It stops the pointer from being as easy to use. And our last one for this section, I think, is the touch screen. So touchscreens are really the up-and-coming thing. They're starting to become everywhere. Even a lot of laptops now have touchscreens as well as the keyboard and mouse for entry. So they're really easy for users, they're fast, they're simple, and similar to a concept keyboard, you can limit them in different ways. So if you go into McDonald's now, at least around here in Indonesia, they have touchscreens instead of concept keyboards. And they just have the pictures, and the pictures are the only method for the icons, sorry, are the only method for entry. So again, you can stop people from hacking if you give them a very limited number of choices on that touch screen. On the downside, although we just mentioned it as partly being a positive, so that's one of the things here. Some positives are negatives, negatives are positive, depending on the situation. So there are limited options with a touch screen. You're limited to what the programmer has allowed you to do. I mean, that's true with everything, but for this case, you can be very restricted. It takes more time to program graphical things. They can, as with mice and other things, they can lead to RSI. So RSI you're going to talk about in more detail in the health and safety section, but RSI is repetitive strain injury. So if you've ever spent 5 days in a row playing Skyrim or some other game, you'll probably be familiar with RSI. It's when you get a pain from using one particular movement too much. So repetitive strain injury. And they're easy to get dirty. So you might be thinking, oh, my mobile phone's quite clean. Well, that's okay because you're the only person using it. But say in a supermarket, sorry, not a supermarket, in a mall. I'm British, but I can't remember the British for mall. Shopping centre. In a shopping centre or in a mall, they often have these big display touchscreens for finding your way now. If you think about how many other people have touched that before you, how much bacteria is on that touchscreen, and how often do they have to come and clean and disinfect it from greasy marks that are on your finger. Alright, so we're now on to another section, I guess, which is direct entry. So we're looking at, as opposed to user entry that we had before. So this is more for humans dealing with things, humans typing out stuff, etc., capturing humor. And this one is more about capturing computer-based or without a person having really to be involved. So our first one is probably very common that you've seen before, is a barcode reader. So, or a barcode scanner, it's often called. So barcodes, they have these little numbers, or they have these lines, and the scanner can use these lines and figure out what the number is. What it will then do is it will reference that number perhaps against a database, and that will tell it what that item is. Is it a can of Coke, or is it a new notebook? So this is really good because it's faster than manual entry. So imagine if the person at the counter, when you go to the supermarket, imagine if he or she had to type out every single number. Sometimes the barcode goes wrong and you have to do that. It takes quite a long time. So with the barcodes, makes much faster than manual entry. It enables auto stock control and price updates. So with barcodes, again, with the product, so maybe let's start in a small shop, maybe they have to put a price tag on every, I don't know, bar of chocolate. It says on the front it's going to cost you, I don't know, 50 cents. So you buy the bar, the person has to key in 50 cents. But let's say they change the price. They would have to go back and update the price on each of the products. Whereas with a barcode, what's going to happen is they just change the database and it's updated for every time the barcode is scanned. Likewise, you can do auto stock control. So every time you scan it, the database subtracts 1 from the amount in stock, and it could potentially as well, if the order falls below a certain amount, it could send for more stock to be sent automatically from the head office. This is a super reliable tech, so I know you're maybe thinking, oh no, barcodes sometimes don't work, but considering the amount we use them, they're very, very reliable, and we've used them for years and years and years. As long as I can remember, we've had barcodes on things, so they're very reliable. And tried and trusted technology, you might say. The downside is they can be quite expensive. You're going to have these on all your products. You're going to have to buy readers. You're going to have computer systems to deal with these things. And that's more expensive than, say, just manual entry. They can also be tricked. It's perfectly possible for you to, buy a single bar of chocolate, you come home, you cut out the barcode, you go into the shop, and then you glue the old barcode, the barcode, on top of a box of 10 bars of chocolate. Now, it might get noticed, I wouldn't recommend you do this, but it goes through the scanner. Is the person that's very busy working in the shop going to recognize that you put through 1 bar of chocolate on the scanner instead of 10? Maybe, but there's different ways that you can trick barcodes, or that people try to trick barcodes. So you've got to be careful. Next one here is, it's not very a good picture actually. So this is the papers, but you can have a scanner that's going to check this for us. And this is called optical mark recognition. Often in the exam they'll just say OMR. So you do have to know what this is. So optical mark recognition is a way of marking tests or multiple choice things like surveys, and you just put the test paper into the scanner and it will collate, or it will calculate the marks for us. It's a really good way of dealing with multiple choice results, and it's more accurate than typing in things by hand. So as a teacher, I often have to mark multiple choice exams. After a few paper, my brain goes dead, and I'm sure I make lots of mistakes doing manual marking of multiple choice, whereas the computer doesn't make those mistakes. It's whatever is circled is what is going to be taken as the answer. And OCR, again, we're going to talk about OCR in a minute, so don't worry about that. Downside, the forms must be clear. If you've ever taken one of these tests, they always go into a lot of detail about how you must circle it, or how you must colour it all in, or it might not be red, because sometimes there's problems with the scanners. And the position when you're putting it into the machine must be accurate for it to figure out your score. If you put it in upside down, the computer doesn't know the difference, so it will just give you zeros for everything. Okay. So the other one that we did just mention there was optical character recognition, or optical character reader as well. So you have a reader that reads these things in. Now, an optical character reader is really just a scanner, and a scanner that uses optical character recognition. So when you scan in, for example, very common for a passport, when you scan in this bottom part of the passport, it will take this first character, the P, and it will scan, say, just that section, or it will take that section of the scan, and it will compare it with other characters in the database, and it will find the one that matches that one. And from that, it can then put that into the computer system, not as an image, but as a typed letter P. Yeah, so you could do it in a word processing document, for example. You could change it. It's not going to scan it as an image. It's going to change that scanned image into manipulatable, that's entirely the wrong word, malleable text. Okay. So this is much faster than manual entry and much more accurate than typing in data. So think of the poor lady or man at passport control. Lots of people, different names from all around the world, strong accents. It would be very hard for them to type out your name. But with this, they just run it through the scanner and they've got that information there. The big downside is it can't read handwriting. So this uses very specific fonts. If you start using strange fonts here, not going to work. Usually there's an agreement on the fonts that they have, or there's a certain variance. If you start using fancy, calligraphy style fonts, it's not going to work. And it can't definitely do handwriting, especially not ugly handwriting like mine. Although this is getting better. I've seen more and more. I know with when I was learning Chinese, they have the handwriting one that can identify the character, so it might not be that far away that they can start dealing with nice handwriting if they don't have it already. And it's not always accurate. Like I said, if the font is not in the database, then it's going to struggle to find it. Or likewise, if there's a mark on here, then it's going to struggle to find that character. So this is OCR. So often they'll ask you about OMR, OCR, because these sound similar. They're trying to confuse you. So make sure you're clear on these ones. Okay, another one we have today. Again, very similar to OCR, but this is magnetic ink character recognition. Honestly, I've never seen this anywhere but on a bank check. And even then, bank checks are very rare these days. I'm guessing we still have them. I haven't seen them for years, but I'm guessing we still have bank checks. So the magnetic ink is not the ink that someone's written on it, but these characters that are built into the check itself. So with the magnetic ink, we can just run it through a magnetic ink character reader, or using magnetic ink character recognition. Again, this is a sort of scanner, but it's a special kind of ink that has magnetic properties. So it doesn't work the same as this one, in the sense that it doesn't read any text. It only reads the special magnetic text that is there. So this is more secure than an optical character reader. And it's more accurate than typing data, and it's more accurate than an optical character reader. However, it works in the same way. These magnetic characters are compared with the characters in the database to find out whose details these are. So who does this check come from? It's faster than manual entry, again, quite obviously, and it's more accurate than typing data. However, it has a limited character set, and it's quite an expensive system, compared, of course, to typing things in manually. Excuse me. Okay, let's have another look. Okay. So we're still on direct entry, but we're kind of getting more into like credit cards and other things like that here. So our first one is a magnetic stripe reader. So these are very common on the back of a bank card. If you look, you'll see if you have a bank card, you'll see a black line going across the back, and this is using magnets basically to store the data. We'll go into how magnets store data in the storage section, but this is a magnetized card and it has some of your information on there. So you just run it through the reader, and that information then goes into the computer. So again, much faster than typing it out. Say trying to type out your PIN number, or sorry, trying to type out your card number is easy to make mistakes. Yeah? It's more secure, so people can't see this. They have to have a reader, they have to be able to deal with it that way. And it's robust. We've used these for years. Reasonably hard to damage, although we're going to talk about that in a minute. But it's a fairly robust, secure system that's worked well for many years. On the downside, it can be damaged. So one problem is that magnets can cause problems with your card. Now I'm not sure if this is true or not, but a student was telling me that they had their card next to their mobile phone and that this caused the card to be damaged. And it wouldn't work in the ATM. I don't know if that works or not, but maybe something to experiment and investigate. But definitely, if you got a strong magnet and ran it back and forward across someone's cards, it's going to cause damage to the card. Humans can't read it, so it's a good thing and a bad thing because it helps to make it more secure. But it means if there's a problem with the reader, then the humans can't directly enter it unless they can get the information from the card itself. And it needs to be in contact with the reader, so it's got to actually connect. Okay. Similarly, we have smart cards. So the smart card is this thing here. So I actually used to work with these, programming them for the UK transport system. I was involved with dealing with these smart cards. And so smart cards are actually little chips. They have information stored inside of them, usually or hopefully encrypted information that you need a specific system to be able to deal with them. So they're more secure than magnetic stripe because they have this strong encryption and you sometimes need a code to get in there. And because of that, they can replace cash. If any of you has a transport card, often they'll now have these smart cards in them. And instead of having to pay the driver, you can buy 10, 15, 100 journeys or unlimited journeys, and then you just use them instead of money. And they can be contactless. So you don't actually have to touch them against the reader, you just have to run them near the reader for it to work. Downside, if it's stolen or hacked, there can be information in here. So if someone is able to hack into your card, they could use this information, perhaps for identity fraud or something like that. So you do have to be careful with your card. Likewise, there's an interesting TED talk. You can look online, but they were showing that people can, because they're contactless, people can sometimes gather your information just by walking past you with a scanner. So if it's in your pocket, you do have to be careful with these because there's no contact needed. People can just walk by with a scanner in their pocket, and if they've got the right encryption sorted, then they could get this information from you. Okay, we're almost there. I know there's a lot of these. Oops, sorry, doubled up. Okay, and our last one is a chip and pin or chip and pin reader. So chip and pin is a smart card. These are it's the same technology. The difference is that chip and pin, you must have the pin in order to be able to deal with, to make the payment. So this is it's basically a more specific type of smart card. This is a secure method of payment. It's very robust, so it's harder to damage these even, I think, than the magnetic stripe. And it can also be contactless, which is good or bad, depending on your security and other things. The downside is, of course, the pin can be seen or stolen. So if someone is looking over your shoulder, they can take the pin from you. For example, not common scam, but a scam I've heard of is, the person working there in the shop, they are very close to you. They can see you putting in your PIN number. If they know it, if they see it, they can signal to someone else, a pickpocket that's waiting. They can pickpocket your card, and they already have the PIN, and so they can access your information. So you do have to be careful with your PIN, of course. So that's maybe a way around it. Compared to signing, though, signatures, it's very hard for humans to identify if someone's faking a signature unless they're an expert. And if you're dealing with thousands of them a day, it's very tiring for the customer service person. So chip and pin is more secure than, say, signing with a magnetic stripe like we used to do. Okay. So, those are our input devices. Now, I'm aware there's a lot of them, and those are just the kind of stranger ones. So I would suggest you investigate them. And a good way for you to investigate is to think about which type of input device would you use in the following situations? And very importantly, why? So if you could write down your answers to this, again, it'd be a good idea, or maybe you can discuss with a partner if you are around. So what would you use in a library? Both for books and for customers, or do you call them customers in the library? I'm not sure. And for the borrowers in the library. For a supermarket. Now, a supermarket, we have EFTPOS. Now, hopefully we'll come back to this again in more detail, but this often comes up in the exam, and it stands for Electronic Funds Transfer Point of Sale. Effectively, it means a place where you pay money in some way, especially electronically. So that could be with magnetic stripe, or it could be with a smart card, it could be with other things like this. Sorry, I'm kind of telling you part of the possible answers, but EFTPOS is electronic funds transfer. How do you transfer funds electronically? And the last one, marking student exams. Which would you use? If you can, try and answer these without looking back at your notes or going back in the video. If you can't, then of course go back and look, but see if you can do it from memory as much as you can. Okay, so just to be clear, in case you're not sure, for each of the devices, you need to know what do they look like. So often in the exam, many of the exams start by giving you some pictures and saying, what's this, what's this, what's this. So you need to know what these things look like. You need to know how they are used. So what are they commonly used for? When would you commonly use a webcam? When would you use magnetic ink, or a magnetic ink character reader or recognition? When would you use a graphics tablet? So you need to know how they're commonly used. You need to know the advantages and disadvantages compared to other similar devices. So if you're talking about a magnetic stripe, you have to be able to compare it to a chip and pin system or payment. And of course, suitable situations in which to use them. So you might be asked, like I've asked you here, to solve a problem, and you should be able to suggest suitable devices. Okay, so I think that's us for today. Now, input devices, there are far more of them than, at least in IGCSE ICT, there are far more of them than output devices or storage devices. So I know this is a big long video with a lot of devices, but you'll come back to them again and again and again throughout your whole IGCSE course. So don't worry if you don't get them first time. Just work on remembering them, and you'll use them again and again throughout your time. So I hope that helps. If you have any questions, comments, or if you want to send in your answers to this, then please, feel free to post, subscribe, and let me know. Anyway, I hope things go well, and good luck with your exams.